Solving equations with decimals, sometimes it's easier to just get rid of the decimals. So let me show you what I mean. If you start with this equation here, 3.7 times x minus 2.5 equal to 6.1x minus 12.2. Now, the directions again say round to the nearest hundredth after we solve. But if you look at this, notice that each one of these decimals is taken out to the 10th spot. So they all have one decimal place. Okay? If they're taken to the 10th spot, or one decimal place, what we can do is we can multiply by 10 to each side. Now let me show you what that does. Okay, let me go through and do keep, change, change, and make these all into negatives here, so we don't lose that. But what I mean is, if we multiply this side by 10, if you go 10 times 3.7, that becomes 37x. Using our distributive property here, and if you go 10 times a negative 2.5, that becomes a negative 25. See how it's gotten rid of the decimal points. Now we can't just multiply one side by 10, we have to multiply both sides, because whatever you do to one side of the equal sign you have to do to the other. So in this case, then I'm going to go 10 times 6.1 and get 61x, plus 10 times a negative 12.2, which becomes a negative 122. Now we're dealing with an equation that doesn't have any decimals. So we can go ahead and solve it. We have x's on both sides, so let's get rid of them on one side. It doesn't matter, again, what side you choose to subtract them off of. So if you go 37 minus 61, you get a negative 24x plus negative 25 equals, double check to make sure these cancel out, negative 22. Now we're just dealing with a two-step equation, so what are we solving for first? Our negative 24x. What do we have to get rid of? Our negative 25. How do we get rid of a negative 25? Well, since it's negative, let's think positive. Whatever you do to one side, do to the other. We have negative 24x. These cancel, equals a negative 122 plus 25 is a negative 97. Divide both sides now by negative 24. This cancels out to give us 1x, which equals negative 97 divided by negative 24. And again, we get 4.04166 dot dot dot. It tells us to round to the nearest hundredth. So we have our tenths and our hundredths. We look at our 4. Oops, I apologize for that. Check out the digit behind it, which is a 1. Since it's a number less than 5, we keep it at 4, and our solution ends up being x equals 4.04. And actually, we probably should have x is approximately equal to 4.04. If we would have solved the original equation without getting rid of the decimal coefficients, we would have came up with the same answer. Because remember, we just did the same thing to each side. So sometimes it is helpful to get rid of your decimal points. It just makes it maybe a little bit easier. Let me show you one more example. Notice in this case, we have 9.45 minus 5.2x equal to negative 8.5x plus 15.78. Okay, so again, the directions are the same. Solve for x, round to the nearest hundredth. I wanted to show you this one though, because look at our decimal points. In this case, we have a number in the hundredths, tenths, and hundredths. When you have ones that are different, you always got to take the biggest one. In this case, and I shouldn't say biggest, it's actually the smallest, but the most decimal places maybe is the best way to say it. In this case, it was the hundredths. Okay? So, and I apologize for spelling hundredths wrong, then the hundredths place. So we're going to multiply each side by 100. Watch what happens. When we multiply this side by 100, 100 times 9.45 becomes 945. I'm sorry, keep, change, change. 100 times a negative 5.2x, you have to move the decimal place over twice. This becomes a negative 520x. Again, because when you multiply by 100, you're just moving it 2 times to the right. And over here, then, if we multiply by 100, 100 times negative 8.5 becomes a negative over twice, negative 850x. Because again, there is a 0 there, even though we don't write it down. Plus 100 times 15.78 is 1,578. If you would only multiply by 10, we would only move the decimal point over once, and we wouldn't have had a whole number or an integer coefficient. We would still have a decimal coefficient. Okay. Then just quickly, if you want to go through and solve this, get rid of your x's on one side. Whatever you do to one side, do to the other. Again, if you would have rather added added 520 to each side, you could. This becomes 945. Negative 520 plus 850 is 330. X equal to, these cancel, 1,578. Subtract now 945. These steps should be coming easier to you the more we do them. That cancels. We're left with 330 times x equal to 1578 minus 945 is 633. Divide both sides by 330. X equals a nice long decimal, 1.91818, and so on and so forth. Since it says now round to the nearest hundredth, tenths, hundredths, our 1 is in the hundredths place. Look at the digit behind that. Since 8 is 5 or greater, we're going to round this 1 to a 2. So this becomes approximately 1.92. Again, if you would have just solved the original equation, ladies and gentlemen, you would have come up with the same answer. But it's a little bit easier sometimes not having to deal with decimal coefficients.